Okay, so today to solve equations with infinitely many solutions, it's going to be the same process as solving any other equation. The only thing is at the very end, you're going to notice that something different happens than getting just a number with your variable. So let's look at the first example. Example 1, and that's going to be 6x plus 4 equals 4 times 3 over 2x plus 1. Now, same process as we do before you even start doing inverse operations, trying to isolate your variables. We want to make this simpler before we start solving. So to make this more simple, we're going to distribute this 4 into the parentheses, and by doing that, the parentheses will no longer be there. Now, yes, that's a fraction, and that's perfectly fine. So what I'm going to do is I'm going to do the fraction operation on the side so that we don't make this messy here. So in this bubble would be my thinking bubble. I'm going to do what's 4 times 3 over 2. So technically this is like a 4 over 1. So 4 over 1 times 3 over 2 means I would have 12 over 2. In multiplying fractions, you just go straight across, and that equals 6. So now I know that 4 times 3 over 2 is just 6. And since it's an x term, it's going to be 6x. And 4 times 1 we know is just 4. Okay, now, as I'm solving this, you might notice that this left side of the equal sign is the same as the right side. And that's true. 6x plus 4 is equal to 6x plus 4. Now, what happens when you have this and you're trying to solve a problem? Remember, we're trying to find what x equals. So in this case, if I plug in a 2 here, 6 times 2 is 12, plus 4 is 16. 6 times 2 is 12, plus 4 is 16. So you're going to always get them equal to each other. So in this case, say you didn't notice and you want to continue to solve it as you usually would, this is what it would look like. I'm just going to switch colors here. So I'm going to keep my x's on this side, my numbers on this side. So this one's fine, this one's got to go. This one's got to go to this side because it's an x term, so I got to get rid of that. And so now that everything's gone, you realize, wait a minute, everything became 0. 6 take away 6 was 0, 4 minus 4 was 0, 6 take away 6 was 0, and 4 minus 4 is 0. And you end up with 0 plus 0 is 0, 0. And that is true. We do know that 0 does equal 0. And when you have a true statement, that means you have x equal to infinitely many solutions. And that just means that x doesn't equal 1, 2, 3. There's no specific number that x is equal to. It means it can be any number and it will make this equation true. Usually we take our x value, plug it back in to check it. And in this case, we can have every single person on earth pick a different number, plug their number in, and this will always be true. And we were able to notice that on this step right here. When you saw the left side equal to the right side, you knew that if we plugged in a 1 for x on both sides, it would be equal. If you plugged in a pi on both sides, it would be equal. If you plugged in a 5 on both sides, it would be equal. So no matter what you plugged in for x, it would always work. And that's what it means when you have infinitely many solutions. Every single number on planet Earth is an answer to this equation. Let's do another one. So for this one, example 2, one-fourth So we're not just going to have one solution. In this case, infinitely many x's satisfy this equation. All right, so here's our next one. Same thing I want to do is get rid of the parentheses so that this is easier to solve by distributing. And we're getting some fraction operation practice over here. 1/4 times 8. We'll put a 1 under that. 1 times 8 is 8. and 4 times 1 is 4, and 8 divided by 4 is 2. So this first arrow is going to give me 2x because it's an x term. And then 1/4 times 12. 1/4 times, we'll make this negative 12. Put a 1 under it, so it looks like a fraction also. Then you get 12 over 4, or negative 12 over 4, and that equals negative 3. Can't see that there. So that means that the second arrow is going to give me negative 3. And again, you notice you end up with the same equation on the left side and on the right side. Now, at this point, I can stop and say, that is true. And when I have a true statement, no matter what x is always going to be true. So we can stop right here and say it has infinitely many solutions. Now, if you're too into the problem and you don't notice it and you continue to solve it, some students keep going until they get 0, 0. That's fine too. If you don't notice that it's equal and you're just busy trying to get this done, right? You want this to be on this side, this to be on this side. No matter what, you end up doing the same thing on both sides because they're equal, and you end up with everything totaling up to be 0, which is still a true statement. 0 is equal to 0. And so therefore you tell yourself, wow, no matter what, the left side will always equal the right side. So no matter what x I put in there, it'll always work. So there's infinitely many solutions. X is all those answers. And that's how you solve equations with infinitely many solutions. It's just an equation where both left and right side will be equal to each other.